You consume it daily. You go through more than you probably realize. You are literally made of it. But how much do you really know about water? Join me, Lake Storywater, and my droid, H2O, as we travel in search of the science behind water and water-related concepts. This is Story of Water. How about this weather? It's probably the most common go-to small talk topic, the weather. Have you stopped to think about what the weather actually is? Weather is defined as the condition of the atmosphere. But what conditions would those be? They include temperature, air pressure, wind speed and wind direction, cloud cover, humidity, and precipitation. The last three are all dependent on water. In this episode, we'll discuss how water affects our weather. Up to 4% of the atmosphere is water vapor. This equates to enough water that if it all left the atmosphere, it would be enough to cover the entire surface of the planet an inch deep.
How come this doesn't happen?
Well, this doesn't happen thanks to the water cycle. The water cycle is the never-ending process of the movement of water from the atmosphere to the Earth's surface. Here's a simplified version of it. This process gets its power from the sun. The sun's rays heat up liquid water on Earth. The water molecules start to move faster as they absorb more heat energy. Eventually, the water molecules start moving fast enough that they gain enough energy to break the bonds that hold them together, and they separate from each other at the surface and evaporate. These water molecules are now light enough to evaporate into the surrounding atmosphere. The next step in the water cycle occurs when the water molecules lose their heat energy. This typically occurs when they cool down higher in the atmosphere. Water molecules start to come together and condense to form clouds. Sometimes the water molecules combine with enough other molecules that they become too heavy to stay suspended in the atmosphere. When this occurs, the water molecules fall as precipitation. The type of precipitation depends on temperature. Once water hits the Earth's surface, a couple things could happen. One would be that the water moves along the surface until it reaches a larger water source that it becomes a part of, where it can begin this cycle again. Another thing would be the water gets absorbed into the ground. Eventually, this water may be found by a plant's roots, and the plant will then absorb the water, and then eventually transpire the water back into the atmosphere, starting the cycle again.
How do we get different types of precipitation?
As I said, it depends on temperature. Let's start with rain. Rain, like all precipitation, gets its start in a cloud. In the cloud are microscopic particles such as dust or dirt. Water drops attach to and form around these particles. If the temperature is above freezing, the drops remain liquid and fall to Earth's surface as rain. Do you think it rains a lot where you live? Well, it could be worse, unless you live in Masinram. This small village, located in the Khasi Hills of northeast India, is considered to be the wettest place on Earth. Air currents bring very moist air from the floodplains of Bangladesh, then are pushed upward and cool when they arrive at the steep hills where this village is located. This brings an average rainfall of 467 inches per year, which, for comparison, is 13 times more than one of the rainiest cities in the US, Seattle, receives every year. Back in 1860 and 1861, a neighboring city, Sora, actually set records for the most rainfall in 1 month and in 1 year. In July 1861, this Indian city received 370 inches of rain, and this contributed to a yearly total of 1,041 inches of rain. The record for the most rainfall in 24 hours occurred in the Folk region on La Réunion Island, which is in the southern Indian Ocean. On January 7th and 8th, 1966, a tropical storm struck the island, dropping 71.8 inches of rain in a 24-hour period. That's almost 6 feet, which is taller than the average person. The most rain to fall in 1 minute happened in Unionville, Maryland on July 4th, 1956. a whopping 1.23 inches fell in only 60 seconds. Although you need above freezing temperatures for rain, sometimes the air temperature near the ground is freezing. This causes things on the ground, such as pavement, to freeze. In this case, raindrops fall as liquid, but when they make contact with a surface that is frozen, they freeze. This is known as freezing rain. Similar to freezing rain is sleet. Sleet occurs in almost the same manner, except that the air temperature is freezing higher above the ground, so the raindrops freeze higher in the air before hitting the ground. Both sleet and freezing rain can be dangerous because they create slippery conditions, which can cause falls when walking and crashes when driving vehicles. For hail, the temperature in the cloud has to be near freezing, as this happens in some storm clouds. Typically, the water droplets freeze when they touch dust or dirt. Then they get blown into the upper part of the cloud, where more frozen droplets attach to each other until they fall to the ground as hail. Most hail doesn't get much bigger than a dime, but they can grow to be much larger. In fact, the largest hailstone by size was 8 inches in diameter and fell in Vivian, South Dakota on July 23, 2010. That's about the size of a volleyball. It weighed 1.94 pounds, but this wasn't the heaviest hailstone ever. That distinction belongs to a 2.25 pound hailstone that fell in Bangladesh in April 1986. Imagine the damage that one of these could cause. Now, snow is also frozen, but it remains as individual ice crystals in the cloud. This occurs when the temperature is below freezing. These ice crystals will combine with other ice crystals to form snowflakes. If you've ever looked at a snowflake closely, then you can see the intricate patterns they make. It is said that no two snowflakes are identical. Snowflakes don't combine with other snowflakes until they build up on the ground. We discussed the wettest place on Earth due to rain, but what about snow? The snowiest place on Earth is in the mountains of northern Japan. Cold air from Siberia crosses the warm waters of the Sea of Japan, gathering enough moisture to produce heavy amounts of snow, similar to lake effect snow in the Great Lakes area. The Japanese Alps receive 1,500 inches of snow per year, or 125 feet. As far as populated areas go, the town of Tokamachi averages 460 inches of snow per year, which is more than 38 feet. In fact, this area also set the record for the deepest snow depth in one measurement, at 465.4 inches in 1927 on Mount Ibuki. In the US, the snowiest place is Mount Rainier in Washington State, which averages 645 inches per year. For the years 1998 to 1999, Mount Baker in Washington State set the record for the most snowfall in one year, which was 1,140 inches, or 95 feet. To picture this, think of 9 regulation basketball hoops stacked onto each other. The most snow to fall in one month occurred in January 1911 in Tamarack, California. 390 inches fell, and this led to snow piling up to a depth of 451 inches when recorded in March of that year. This location is in the Sierra Nevada mountains. The heaviest recorded snowfall in a 24-hour period fell on April 14th through 15th, 1921 in Silver Lake, Colorado. At this spot in the Rockies, 75.8 inches, or 6.3 feet of snow fell. Now this storm only lasted one day, but what about if a storm produced a prolonged snowfall? For the 7-day period beginning February 13th, 1959, 189 inches, or 15.75 feet of snow fell on Mount Shasta in the Cascade Mountains of Northern California. Well, I think that's enough talk of cold weather events. Let's move on to warmer weather. Have you ever experienced a summer day where you felt hot and sticky but couldn't cool down? Then you know what a humid day feels like. Humidity is the amount of water vapor present in the air. The more water vapor in the air, the higher the humidity. Why is it so difficult to cool down when it is humid out? Well, first off, how do we cool off as humans? We sweat. But it isn't the sweat itself that cools us, it's the process of sweat evaporating and taking the heat the sweat has stored away from our skin. Now on a humid day, the air is holding a lot of water vapor. In fact, it may be holding so much that it can't take any more water, so the sweat on your skin is unable to evaporate. This is that muggy feeling. When the weather person tells you the humidity percentage, they are referring to the relative humidity. This is the amount of water vapor in the air at a certain temperature compared to the maximum that can be held at that temperature. The closer to 100%, the more humid it is. If the humidity is 100%, then the air is considered saturated and can't hold any more water vapor. The temperature this occurs at is known as the dew point. So the higher the dew point, the muggier it feels. The record for the highest dew point, and therefore the highest humidity ever recorded, was 95 degrees, which occurred in July 2003 in Dhahran, Saudi Arabia. Perhaps on another summer day, one not as humid, you may have laid on the ground and looked up at the clouds, imagining the clouds looking like animals, people, or other things. Maybe you flew in an airplane and went through the clouds so that you could look down on them. Have you ever wondered what clouds are? What they're made of?
Yes, what are clouds made of?
Clouds are tiny water droplets or ice crystals. Once air cools to the dew point, condensation occurs and clouds form. The different types of clouds were first categorized by British meteorologist Luke Howard in 1803. He is the man who got to name clouds, and he divided them into three main types: cirrus, cumulus, and stratus. Today, the World Meteorological Organization recognizes 10 cloud types. The high-level clouds are the cirro family. Cirrus clouds are the high, wispy clouds. These clouds mean pleasant weather for the next 24 hours, but then a change to stormy weather after that. Cirrocumulus clouds are small, rounded, puffy clouds that are arranged in rows. Think of a fish scale pattern. They are seen mostly in winter because they mean cold, fair weather. Cirrostratus are thin clouds that cover the entire sky like a sheet. They usually mean a storm is coming in the next 12 to 24 hours. Next are the mid-level clouds, the alto family. Altocumulus clouds are puffy clouds that appear in groups. Seeing these on a humid summer day means a storm may be coming. Altostratus clouds look like one entire cloud-covered sky. They mean heavier snow or rain is coming. Nimbostratus clouds are dark clouds that produce precipitation. Last are the low-level clouds, the stratus family. Cumulus clouds are the white, fluffy, cotton ball type, usually what people think about when they imagine clouds. They appear on days with pleasant weather. Stratus clouds are clouds that cover the entire sky like a blanket. Stratocumulus are low, dark, puffy clouds that form in rows, and although they look like they contain precipitation, they rarely do. Cumulonimbus clouds are thunderstorm clouds. They sometimes look like an anvil with their flattened top. They grow from the low levels upward in the atmosphere. If you see one of these, you know heavy precipitation is likely. In addition to these clouds, fog is basically a cloud on the ground, and like clouds, it forms when water vapor in the air condenses. That's why fog mostly occurs in the morning or at night, when the air temperature cools to allow condensation.
Where is the cloudiest place on Earth?
So where's the cloudiest place on Earth? According to Edward Grispiert of the Imperial College London, that title belongs to El Danubio, Colombia, with an average cloud cover of 98.6%. It is so cloudy because moist air from the Pacific Ocean blows over the warm air in this region, causing clouds to form on an almost daily basis. Our weather can vary greatly, not only from day to day, but from location to location. As we discussed, water is a big part of weather, and there are many extremes that water gives rise to. So next time someone asks you about the weather, you can share some of the interesting facts you learned today. Thanks for joining us on Story of Water. If you liked what you heard, why not subscribe to this podcast on your favorite podcast provider? Let your friends and family know about it as well. Connect with us and listen directly at www.story-of-water.com. Check out the blog or email us feedback. If you really enjoyed the show, become a Patreon supporter. Just click the donate button on our website. Remember, stay hydrated. See you next time on Story of Water.